Hello, this is Mr. Collier, and today we're doing some applications of polynomial functions. So we take a look at this complex function here. We have an asymptote here at x equals 0, and you have like basically two separate parts to this graph. One is right here on the left of the asymptote, and one's on the right of the asymptote. We are going to be first finding the x value of the local minimum. So what local minimum means is, well, basically this function doesn't have a minimum because this part of the function goes down this way forever. There's no global minimum. But if you look at this region right here, over in the quadrant 1, there is a minimum value right here, which we call local minimum, because it's a minimum in just this area right here. Okay, so we're going to find that value using our GDC. So when I go to graph this, I'm going to type it in and graph it. And I'm going to use the window from -4 to 4. So -4 to 4, and I'll just keep the y value the same and see what happens here. Okay, we can't see it all, so I'm going to change the y min from, well, I'll keep the y min the same maybe. Change the y max to 10. Okay guys, I can see it a bit more now, and I'm going to try to find this minimum value. So you go to second function, trace, go to minimum, which is number 3, and left bound, right bound. Let's see, I can't see the cursor right now. Okay, that's to the left, and this is to the right, and I'll guess right there. And there we can see the x value at the minimum is 0.693. So that's 0.693, rounded to 3 significant figures. Find the solution of the equation f of x equals 0. So what that means is, well, this is f of x. When f of x equals 0, we have the x-intercept, so that is f of x equals 0 right there. So we're going to find the solution of f of x equals 0. We're just going to find the x-intercept, and on your calculator that they refer to that as the 0 of the function. Okay, so I'm going to go over towards that x-intercept to get the left bound. Then I'm going to go get the right bound. Then I'm going to go directly on to that x-intercept. And we get negative 0.874. Negative 0.874. Alright, and you can say actually x equals that, so that's the value of x at the x-intercept. Graph g of x equals 0.5x minus 5 on the same axes. So that's going to be a y-intercept of -5, and the slope is half. So we could go up 5 and right 10. That's going to be pretty big slope, or pretty far out there on the graph. So I'm going to graph that on the calculator. Let's see what that looks like. 0.5x minus 5. So that's what it looks like. I'm going to change my window now to, I'm going to change the y min to be -10. Oops. Alright, so that's what it looks like there. So let's just kind of basically sketch that right here. So we do have one point of intersection right there. So part D here, in part D, we're going to solve this equation. Now this is oh, that should be 2 out of x there. This part here is f of x. Alright, and this part here is minus g of x. So basically we're solving the equation f of x equals g of x. And what we're doing is actually finding the point of intersection. When you find the point of intersection, you've solved the equation of f of x equals g of x. So we're going to find the point of intersection. We're going to go to second function, trace, and intersect is number 5. Which curve am I on? Okay, so I'm on that curve. I'm going to press enter. Press enter. I think I can just press enter again. And there's your point of intersection. That is your point of intersection is, let me just copy that real quick. So that's the point of intersection is, oops, let me do that in green here. That point is negative 0.359, comma, negative 5.18. So your solution to this equation, notice there's no y in this equation. The solution is just the x value at the point of intersection. So your solution is x equals negative 0.359. Okay, on to another example. Okay, in this example here, we have a cube, or cuboid, so these are not necessarily all the same. Has a square base of x centimeters. The volume of the cuboid is 500 cubic centimeters. Write down an expression for the volume of the cuboid. So the volume is going to be just x times y, which equals x squared y. And in part B, we're going to find an expression for the surface area in terms of x. Alright, so surface area, you've got basically 3 types of sides here. You've got an x by x on the bottom, then you've got an x by y, and well, you've got 2 of each of those. And also, that's the top and bottom, you've got x and x. You've also got another, well, actually you got 4 of the x times y sides. Alright, because this is x times y, this one's x times y, that one's x times y. All the ones on the side are x times y. So your surface area is equal to 2 times x plus 4 times x times y, which equals 2x squared plus 4xy. Now we want it in terms of x. We did not want this y here. So what we need to do is write y in terms of x, and we can do that using our volume. Because we know the volume equals x squared y, we know that 500 equals x squared y. Alright? So to get this in terms, or get y in terms of x, we divide by x squared. We get y equals 500 out of x squared. So our surface area equation becomes 2x squared plus 4x times, now y is going to be 500 out of x squared. Okay, and that equals 2x squared. 4 times 500 is 2,000. And x to the power of 1 divided by x to the power of 2, we get just x. So this is our equation for surface area. Okay, we're going to graph this function now from 0 to 30. So let's do that. I'm going to go to y equals and clear these functions. Alright, so we're going to graph this function, which is 2x squared plus 2,000 divided by x. And a window, I need up to 30. They tell me to graph it up from 0 to 30. So 0, 30. And the surface area, I know the surface area can't be negative, so I'll just go from 0 and I'll, the y value, maybe I'll guess 100 or so. Or maybe 1,000, I think it's going to be bigger. Okay, wow, okay, that's a good graph then. We can see what we want to. We can see the local minimum, so that's probably what we're going to be needing next. So actually, let me sketch the graph right here now. Let me grab this. Try that again. Okay, there it is. Alright. So I'm going to be sketching the graph and just include maybe the scale of it here. This is 1,000. This is 30. And here's what the function looks like, something like that. Okay, that's y equals negative 2x squared plus 2,000 out of x, and that's what it looks like. Okay, the next question, I believe it asks you to find the minimum right there. Let's see. It says find the dimensions that give the minimum surface area. So we're going to do that with our GDC. We're going to go to second function, trace, and go to minimum, which is number 3. We need a left bound, so we need to go to the left of that minimum point. I think you can just type in a number too, like maybe 6. And it goes to 6? Yeah, it does. Okay. And right bound, let's go over here to like, is that 8 over there? Let's just use 0. Okay, I'm at the right, now guess right on the middle. And there we get, so that is, let me paste it again. And for some reason it goes up to the top here. Why? Okay. So, we've got this minimum here is 7.94 and 378. Alright, so looks like the max or the minimum surface area is 378, but the question asks for the dimensions that give the minimum surface area. So that means what are the length, width, and height of the cuboid. So that's the x value right there. So the x value is 7.94, and that gives you your minimum surface area. So recall the cuboid looks kind of like this. So this is 7.94, this is 7.94, and then we have the y over here, which we don't know right now, but we know that y equals, let's take a look at this, y equals 500 out of x squared from before. Y equals 500 out of x squared, so that's how we can find the y value now. So y equals 500 out of x squared. So y equals 500 divided by, now to get the most accurate answer actually, I'm probably going to use some more decimal places of x here. So 7.937 I think I'll use. 7.937 squared, which equals about, and let's do that on the calculator. Okay, 500 divided by 7.937 squared, and I get the same thing. That makes sense. So basically it has the minimum surface area when y is equal to x, then you have like a cube rather than a cuboid. So y is about also 7.94. Okay, so your answer to the question is the cuboid is, has a minimum surface area when x equals 7.94 and y equals 7.94.